There is a deployment funnel that almost nobody talks about. 60% of AI projects get evaluated, 20% make it to a pilot, and only 5% actually ship. MIT tracked 300 real implementations against profit metrics to find out why. The answer is not that the algorithms are bad. The real problem is a massive infrastructure mismatch where hardware chosen for evaluation cannot sustain production scale. By the end of this video, you will understand the specific technical capability gap in inference hardware and latency economics that kills your project before it ever reaches a customer. Most engineers make a fatal mistake right at the start. They treat evaluation and production as the same environment. They run a proof of concept on a small dataset with static benchmarks and celebrate when the model hits high accuracy. This creates a false positive. The system works perfectly in the sandbox, but the moment you try to scale it, everything collapses. The failure is not algorithmic, it is infrastructural. You have selected hardware that is fundamentally incapable of handling the realities of the real world. Here is the thing about evaluation environments. They often utilize static, low-latency benchmarks on small datasets. These tests fail to capture the memory bandwidth saturation and context window explosion that are inherent in production inference. A model might run smoothly on a single GPU with a few concurrent users. But in production, you are dealing with persistent state management and multi-step tool calling. The evaluation sandbox does not simulate these workflows. This leads to hidden latency accumulation that kills the pilot before you even notice the problem. Consider the concept of the Inference Economics Cliff. This is where the cost per token scales non-linearly with concurrent user load. A system might be perfectly viable for 50 users, but financially unsustainable for 50,000 without a complete architectural re-engineering. Most failed pilots rely on CPU-based or single GPU inference stacks that cannot sustain the P99 latency requirements of production systems. They create a false positive during evaluation that only manifests as a system-wide timeout cascade at scale. You think you have a working product, but you actually have a financial liability. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The research on enterprise agentic AI confirms a critical deployment gap. While 85% of companies experiment with AI, projects frequently stall after the proof of concept stage. This is due to a misalignment between benchmark accuracy and production realities. Agents demonstrating 60% success in isolated tests often drop to 25% consistency in multi-run production environments. The gap is not in the intelligence of the model, it is in the environment where the model lives. This brings us to the core of the technical capability gap. Engineering teams frequently optimize for model accuracy during the evaluation phase, while neglecting the cold start and context window costs that dominate production total cost of ownership. They choose hardware based on speed in a vacuum, not on economic viability under load. The result is a technical capability gap where the chosen hardware cannot economically sustain the required throughput. You end up with a system that works but costs 4.4 to 10.8 times more than a cost-aware alternative. Now consider the metrics you are actually measuring. Optimizing solely for accuracy results in systems that are vastly more expensive. The data shows that cost, latency, and reliability metrics correlate 0.83 with production success. This is far outperforming accuracy. Only metrics which only correlate 0.41. You are measuring the wrong thing. You are chasing a number that tells you nothing about whether your system will survive in the wild. There is a deeper layer to this failure that we must address. Broader academic analysis suggests that 83% of current evaluations neglect human-centered and safety factors. This implies the failure is not just hardware but also a measurement imbalance. You cannot simply swap out a GPU and expect your system to succeed if the workflow itself is flawed. The infrastructure mismatch includes unmeasured workflow and trust issues. The technical capability and economic viability are equally critical bottlenecks, preventing the transition from pilot to shipping. The solution requires a fundamental shift in how you approach deployment. You must stop treating evaluation as a standalone test and start treating it as a stress test for your entire stack. Your evaluation environment must simulate the memory bandwidth saturation and context window explosion of production. You need to measure cost per token alongside latency and reliability. If you do not optimize for these factors from day one, you will hit the inference economics cliff and your project will stall. This reframing changes everything. The 6% drop-off is not a management issue. It is a technical capability gap in inference hardware and latency economics. When you align your infrastructure with the realities of production, you stop seeing the 25% consistency in multi-run environments and start seeing the robust performance required for shipping. You stop building prototypes that are too expensive to run and start building systems that are sustainable at scale. The path forward is clear. You must audit your current evaluation pipeline. Are you measuring cost and latency, or just accuracy? Is your hardware capable of handling the P99 latency requirements under load? Can your system manage persistent state and multi-step tool calls without collapsing? If the answer to any of these is no, you are not ready to ship. You are just running a very expensive proof of concept. The difference between a failed pilot and a shipped product is not the model. It is the infrastructure. It is the understanding that evaluation and production are not the same. It is the realization that accuracy is not the only metric that matters. By focusing on the technical capability gap and the economics of inference, you can bridge the gap between the 60% that evaluate and the 5% that ship. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.